Good day, everyone. So today we are going to learn on energy analysis by using Revit and Insight 360. So with Revit, as well as Insight, which is using cloud service, you can analyze your design, the state of your current design in terms of the energy performance, as well as the usage of energy for your current design.
Energy simulation can basically help you to analyze the movement of energy in as well as out and through the rooms and volumes in your building. So this information can basically help the designer to make a better informed, cost-effective decision that will somehow improve the performance and reduce the environmental impact of building.
So these are basically some of the examples of the design where you can send out this model or to the cloud to be analyzed in terms of the energy usage. So you can conduct this energy performance analysis as early as the conceptual stage, where you can use conceptual massing or massing to test the current energy performance of that particular design, or uh, during schematic or detailed design development. So in this case, this stage will be more appropriate to our situation where you guys have already designed the model for during your project one. So in the detailed design or the schematic design level model, I believe you guys have assigned uh, some certain properties or materials to the design. So in this case, some of the materials might have the analytical properties which would be important in the energy analysis later on. So the analytical properties is basically all the thermal properties that is required to conduct the energy analysis. In this case, for example, for your walls, you might have assigned a brick wall. So this brick wall might have its own uh, thermal properties that will be important in order to be included in the energy analysis later on. All right, so these are the example of the design being sent out in Set 360. So once you have finalized your design, you can send it out to Build 360 for energy analysis. So in this case, when you open up, you will see there's a lot of charts, there's a lot of reports uh, reporting the current energy consumption of your design. So you'll be able to review it at each of these widgets, and you can also decide the best solutions in order to optimize the energy usage of your design. So in overall, these two will help you to assess the overall energy performance of the design, thus making your building to become an energy efficient building. It will also support as a decision tool. It this is this is the importance of doing the exercise as is a tool to support the decision making and want to develop the design. So in this case, to optimize your design by benchmarking with several green standards. So in this, for Insight 360, you are able to benchmark your energy, the design energy usage with ASHRAE 20.1, as well as uh, you can also cross refer to GBI as well as building energy index under Malaysian standards. Uh, Another thing is that so once you have sent out your design to the Insight 360, it will consider as a baseline So as you have made changes or any revisions to your design further on, you can resend back the model to an Insight 360 to further to further compare the, the the amount of reduction, energy reduction that has been applied to the design. So in this case, you are able to track back, okay, the development of the design from as early as the base, as early as the baseline stage, all the way to the optimized stage. So it is very good to somehow track the progress of it. So these are basically the steps in creating your energy analysis. Uh, Firstly, you are required to prepare your all your building elements. As you know, in Revit, you have building elements which consist of walls, floors, roof, and so on, windows, doors, and so on. So you will need to assign certain materials to these building elements because the materials in Revit, they have these analytical properties in it. So these analytical properties will be very important in conducting energy analysis. So analytical properties is basically the thermal properties, for instance, the R value as well as the U value of that particular material. So it is important that you need to set this in your design uh, before you send your model to Insight 360 for further analysis. Secondly, you are also, it is important that you need to set the rooms in the design as well, because for energy analysis in Insight, they require you to have some to determine the space as well as area and the volume to be computed in that model. So you you need to ensure that your room, all of the spaces in your room can be assigned with this room, okay? As well as you need to set the volume of each of the spaces as well in order to maximize the analytical space and surface for your energy analysis. Thirdly, you need to set the location of your building. So in this case, by using Revit, you can set the location of your building, the actual coordinate of the building, and you can also orientate your building accordingly inside. And then after that, you will need to set the energy setting of the building. So this is very important to ensure or to ensure your building is to ensure the type of your building, the occupancy of your building, and so on. And then after that, once you have set the energy setting, you will need to create the energy model. And once the energy model has been generated, you can upload the energy model to cloud. So as you know, Insight 360 is basically a cloud service. Okay, so you can just send it out to the cloud. And once the model have been analyzed, Insight will somehow inform you by email. And so, and then lastly, so once the model has been prepared, you can basically analyze and optimize your design for further energy improvement. So before you start, please ensure that you install this Insight plugin because some of you, when you install your Revit, there's no, when you look at the analyze tool, there's no solar radiation as well as daylighting options. So you might need to install the plugin into your Revit. So in this case, you might want to go to this link inside 360.autodesk.com/onenergy/landing/downloads and download this plugin, install it into your Revit. So this is very important. Make sure that you um, do this before you start analyzing the model.
Okay, so now let's proceed with our demonstration. So I have uploaded this model in Times. It's basically the same model that you use for during our computer lab session. Okay, so we are going to prepare this model for energy analysis. So it is important that you guys need to follow all of these steps that I have mentioned in the previous slide just now. Right, so the first step is basically we want to prepare your model in terms of the elements of your model and assign it with materials. Okay, so this is where you need to check all your building elements, the walls, the floors, the roof, whether uh, the materials that has been associated with thermal properties has been associated to that particular element. So how to check it? So this is where you can click the wall, any elements within your building, perhaps the wall. So you notice that the wall has been assigned to a parameter that I have created before this. So it's a brick wall with plaster. So if I edit the type, it will display out the analytical properties of that particular brick material. So this is the information that is very important when you want to conduct your energy analysis, such as the R value, the thermal mass information, and so on. So let's say if you want to view the property in detail, the property of that material in detail, you can just go here under construction, under the structure, there's an edit tab. Okay, okay, so this is the total R value for this wall. So it's been displayed here. But if you want to view the breakdown of that particular, the thermal property of that particular materials within that wall, you can just click here under the materials, under thermal. Okay, so it's displaying all the analytical properties of that particular material. Okay, the thermal conductivity, the heat, the density of the material, emissivity, which all of this information are very, very vital in conducting the energy, the whole building energy analysis. Uh, okay, so not just brick, all the materials that is standard in Revit, it has this information. Okay, so there's no need to change it actually. All you have to do when you want to assign your elements, you just need to assign these materials into the elements and it will read whatever information that is, whatever thermal information that has been associated to that particular material. So unless if you are using analytical materials, for instance, generic materials, then you might want to add your own thermal properties. Okay, so these are all analytical slab, analytical force surface. These are all generic materials. Okay, it is all conceptual materials. There's no actual information being associated to that material yet. So if you want to add generic materials within, if you have a generic materials within your building, it is important that you need to specify the thermal properties of that particular generic material. But in this case, I think it's best that you just assign with whatever standard materials that you have in Revit. Okay, for example, if it's a brick wall, then just assign the brick material to that brick wall. If it's a concrete wall, then you can just assign a concrete material to that wall because all of this information has been predetermined in Revit. So it's very easy. So there's no need to do anything. This is just to explain how the thermal properties is associated to the material. So just click OK. No need to change anything. Okay, so basically if you not inspect the model, everything is already embedded. The material for the roof. Okay, if you click edit type, you can see that there's an analytical property there. Unless if your building is using, if your wall, perhaps any elements within your wall is using generic materials. Okay, like for instance this part, this is a generic wall. If you edit type, then you will not able to see the analytical properties because there's no materials associated to the generic wall yet. Okay, this is just conceptual. So notice no material has been applied, therefore no thermal information for that particular material. So it is important that all the if you want to do analysis at the design development stage, you will need to assign all of these elements with a specific materials. Okay, so in this case, I assign by with the same material, which is the brick plaster material for this particular wall. Okay, I'm happy with all of the materials. Maybe the only thing that I want to change is perhaps the glass. Right now, let's look at the glass. Remember, if you want to select individually, you need to press that button. So I'm selecting the glass. If I edit type the glass, notice that the glass that I'm using for the window is 1/8 in Pinkerton single glazing glass. So maybe I want to change the glass to low E or perhaps a reflective glass for better energy efficiency. So what I'm going to do, I'm going to select the glass, right click, select all instances visible in view. So what it's going to do is going to select all the families that shares the same property. So click edit type. Okay, so I'm going to change the material to maybe low E double, maybe low E double glazing, or maybe maybe just maybe we start with a baseline first. Don't need to go with the advanced material. So we'll start with a single glazing. So this is okay. So all of this glass has been assigned to a single glazing CO2. So these are the thermal values for that particular material. All right, that will be it for the materials. So next, we need to prepare the rooms in the model. Okay, so in this case, you will need to insert rooms in order to detect the analytical space and surface of that model. Okay, so it's important that when you want to insert room, you need to also include the volume as well. Okay, so how to adjust the volume, I will show it. I will show it now. Yeah. So before we want to place the room into the plan, make sure that you go to this option under architecture, room and area. Go to area and volume competition. Make sure that the areas and volumes are turned on, not areas only. Okay, but if its area is only going to calculate the area, it's not going to calculate the volume. So you need to include both aspects when you want to do energy analysis. So just click OK. So you can't place your rooms in your 3D view, so you need to go to the plan view. So go to level 1, click room, and simply place the rooms in all the spaces in your model. Okay, I've put in level 1 as well as in level 2. Okay, so I have placed the rooms in. So how do we check the volume? Well, how do we check whether this room tag is covering the total volume of the space? So this is where you need to cut a section. So go to view, go to section tool, and put 2 sections. Okay, put 2 sections. Okay, so now let's go to this section, double click. Okay, right now you can't view the room because it's hidden. So if you want to make it appear, you need to go to view, go to visibility and graphics. Or you can just type double V, VV, it will open up this visibility graphics options. So go down and try and find the rooms. Okay, here, this is the room. If you expand this, notice that the interior field and the reference is is hidden. So if you need to check both and then click OK. So it will display out the rooms. Okay? It will highlight out the infill of the room. So notice that for the level 1 up to level 2, I think it's fine because it's covering from floor to soffit of the upper floor. So it's covering, the volume is covered. But if you look at from the level 2 upwards, it's only covering up to the top of the beam. Okay. By right, we want to compute the whole space, meaning all the way down up to the soffit of the roof. So how to adjust your room is simply by pointing your cursor to the room and using this control button, you can just like drag it up. So notice that the room is fully covered lah. Okay. What Revit is going to do now is going to calculate the total volume of the space, which is very important when you want to do energy analysis. Yeah? So it somehow increases the analytical space and analytical surface for your energy analysis, and we also make sure that your model or your analysis will become more accurate lah. Okay, if it's not covering the whole volume, you will not get an accurate reading for your energy analysis. Okay, so next is what you have set your room. Next is to set the location of your building. So in this case, you need to place your building to the side. So indeed, basically our site is the same. We are using the one in Taylor's University next to the commercial block. Okay, how to set the location? Go to Analyze and go to Energy Optimization. So this is, all of this option is concerning to energy analysis. You just need to refer to this. So go to Location. Go to, okay, right now it's referring to Boston, Massachusetts in US. So you might want to type Kuala Lumpur and search. Yeah, click this. Okay, so it's going to direct to Kuala Lumpur, but this is not the actual site. You need to move this icon to your actual site. So our site is basically at Taylor's University. So we need to find it. Where is Taylor's? Taylor's, I think, is at Subang Jaya. Where is Subang Jaya? Subang Jaya, where are you? I think it should be around, yeah, I think it should be around here. Okay, so where's the V? Okay, just drag this, drag it, and place it near your site. Where is it? Okay, I got lost here. Hold on. Yeah, it's around here. All right, here, it should be here. Okay, so just place this point to the campus, which is the site next to the commercial block. All right, so we have placed the icon to the side. As you notice, there's this icon here. This is basically referring to the weather station. So what Revit is going to do when you place an icon to the side is going to refer to the nearest weather station. Okay, so in this case, I think this is the nearest one. So whatever data is going to be referring to this weather station. Okay, right. So we have set the site. Apart from that, if you go to the weather tab, you can also see the annual weather readings, the high as well as the minimum temperature throughout the whole year. So you all display here. It will be very beneficial if you want to read the annual weather for this particular site. Okay, so just click OK. So now we have set the location. Next is
to set the energy setting for the building. Okay. So to set the energy setting, it's best that we go to a 3D view. To go to a 3D view, in the same tab, there's this option called energy settings. So just click this. All right, so there are several settings that you need to change in this panel. So right now, if you notice that this building is a detailed building elements. We are not using nesting for this design. So you might just change this to use building elements. Okay. So unless if you are designing your building at a conceptual phase where you use conceptual mesh or meshing to build up the form, then you might want to use conceptual meshes only. Okay. Or perhaps if you have both conceptual mesh and building elements within the same model, you can opt to use this option. But in this case, there's no conceptual mesh in this model, so I just change to use building elements. And then make sure the ground plane is also set. The ground plane is set at level 1. The project phase is new construction. So analytical space resolution and surface resolution is basically referring to the rooms that you have put in just now. So these are the total analytical space and surfaces that is being generated by the rooms. And then you might want to go to advanced settings. Well, all right. So for the detailed model here, if you are using conceptual model, you can basically change the targeted glazing, percentage of glazing, the targeted seal height, the shade depth, the skylight width and openings. You can basically change. It has the flexibility to change. Why? Because conceptual model is still conceptual. You have the flexibility to change any of the surfaces and so on. But in this case, we are using detailed elements or detailed buildings as our model. So that's why you can't change all of this unless if you are working with meshing. You have the flexibility to change all of this because, of course, it's a design, it's a conceptual design process. So a lot of things is still it's not tangible. So you can just manipulate the settings and so on. Building data is about the building type, the information about the building. So in this case, you need to change the building type. Okay. So yeah, it's an office building. We are just remaining as office. Okay. The building operating schedule, you can change the operating hours for the building. So usually office is either 24/7 or 12/7. But in the meantime, I just leave it as default first. And then HVAC system, you can set the air conditioning system for the building. So there's a lot of varieties of aircon systems that you can basically explore. So this is where you need to you need to conduct a bit of study lah. You need to study which aircon that might be suitable to be applied for your building. So in this case, I just maintain central VAV. There's no changes. I only change the building type to office. And another important is the material thermal properties. Within this conceptual schematic and detail element phase, you can basically change the materials. Okay, but in our case, we are in detail element phase. All the material has been changed in the model, have been assigned in that model itself. So there's no need for us to actually change the materials of that of these pages lah. So unless if you are working with building meshing or conceptual meshing, this is very important. You need to set the material for your meshing. For instance, the wall, the roof, the slab. You will need to set the actual construction the actual materials for that particular meshing. Schematic types, like I said, some materials within the building might be a generic model. So you still haven't specified the material in detail yet. So that's why Revit gives an option to the flexibility to assign those materials into model. So you can override that generic model with these materials. You can just there's a lot of materials. For instance, the roof. All of these are materials for the roof. Yeah? It's a lot. This is for the exterior walls. Okay, the ceilings. You also display out the U values as well, so you can basically know the performance of all of the materials. So you can choose to override that. Let's say, for instance, your current ceiling in the model is using a generic material. So if you want to override the ceiling material to a certain material, you just need to click override. Okay. But in this case, all of the materials have been set before this, yeah, in the model. So there's no need to actually change the schematic type. The only thing that you need to check is basically the detail element. So detail element, once you check, it's going to override all of these settings. Okay, so it's going to override all of the settings and it's going to refer to whatever material that you have put in your model. So make sure you check detail elements if you want to analyze the building during the during the detail element phase. So click OK and click OK. Okay, so we have set the energy setting. Next is to create the energy model. Okay, so to create energy model is simple. Just need to click this button, create energy model. So click this. So it's going to convert the model to an energy model lah. So when we talk about energy model, it's all analytical surfaces. These are all analytical space and surfaces lah. It is based on the setting that we have created just now. So yeah, so Insight will use this model to basically analyze the energy performance of your building. So if you notice on the roof, you see it's been break into several categories. Okay? For instance, here, this part is one category, this is another category. This is because Revit or Insight is identifying this as a sunshade. So it will somehow contribute towards energy reduction as well. So that's why it's been break up to several categories. Okay. All right. And then after that is once you have created the energy model, this is where you will need to send this energy model to Insight for analysis. So if you send this model to cloud, okay, so make sure that you have your student subscription for Autodesk. If you don't have any student subscription, then you might encounter some problems on delivering or uploading this model to Insight. So make sure that your student account, your student Autodesk account is activated. Okay, to generate or to send the model to Insight, you just need to click generate. Click generate and update an energy analytical model. Okay, so the process is complete. The energy analytical model has been successfully created. So all you have to do is just to wait until you receive a notification or an email from Autodesk that your analysis has been completed. Okay, but you can straight away go to Insight from Revit. Okay, just go to optimize. Okay, this button optimize. So it will direct you to the Insight cloud platform. So as you see here, so this is the analysis that I have sent to cloud. It's currently in progress. The analysis is basically in progress. So we need to give some time for the model to be complete. More detail, the model of course is going to take a lot of time. It's going to consume a lot of time. So yeah, we just wait until the analysis is complete. Okay, so now the analysis is complete. So if you want to view your,
if you want to view your model, you can just click this icon. So it will display out the energy analysis of the model. So this is the building that we have run the analysis to. So if you scroll down, it will display out all of uh, all of these widgets is basically informing the current energy usage of the design. Yeah? So right now, if you notice at this tab here, this is showing the current energy consumption for this building. So as you notice, the value that I get is 18.3 USD per meter square per year. So if you want to change to kilowatt kilowatt hours unit, you can just click this widget. Okay, so this if you convert to the kilowatt hour per meter square per year, I will get around 198. So inside you can basically benchmark your energy your energy consumption with ASHRAE 90.1. So if you notice under ASHRAE 90.1 for office building, the benchmark is around 168. So what I get here is quite above of the amount. So this is where we need to look at all of this information, all of these widgets that would display out all the charts. Okay, so it basically explaining the current situation, your design situation, and how what are the best option in reducing the energy usage of your building. So there's a lot. Okay, there you can look at the building orientation. You can have a look at the window shades, the window to wall ratio on every facade. Okay. Even the window glass, what's the best option to use for the windows glass, the wall construction, roof construction, there's a lot. So all of these widgets display out these charts showing the current energy usage in the design and how you can actually uh, manipulate these options in order to optimize your design. Okay, so now let's try and analyze several widgets. So we're going to look at the building orientation first. So as you can see, this triangle shape icon is basically showing this is representing the design. So this is what is being uh, placed or inserted in the design. So and all of these are basically the options that you can somehow revise in order to optimize the energy performance of your building. So if you notice in building orientation, it doesn't really significant. Okay, so if you want to change, if you want to orientate your building 180 or 90 or 155, it doesn't really make any difference in terms of the energy reduction. I don't know why. Maybe because the building is not that high, so that's why if you want to orientate, it doesn't really contribute to the reduction of energy. So I might just ignore this for a while, and then let's look at perhaps we're going to inspect the east to west sun path. Okay, so let's check on the perhaps the west is the most significant. So maybe by adding more shades or by playing with the window to wall ratio in the western facade, I will be able to reduce some energy. So let's look at the window to wall ratio for the western wall. So you can see that this is the current situation, the current value that is in the model right now. It's 56% window to wall ratio. But let's say if I can reduce the window to wall ratio to 0%, so meaning there is no window at all at my western facade, I will be able to reduce by around 190. I will be able to reduce about 8 kilowatts by not putting any openings at my western facade. Okay, so yeah, maybe I can just use this as one option, so 0%. So in total I will be able to reduce up to 190. All right, that can be one option to revise my design. But still, if you notice, we want to at least achieve the actual requirement. So there are still a lot of things that we need to play around in order to you know to have further reduction. So why not we have a look at the window shades, meaning the sun shadings on the western facade. So maybe there's something that we can do about it. Or there's not much difference whether you want to use 2/3 of the height of the window height or 1/3, one out of two of the window height. It doesn't really make much difference. So in this case, I can just ignore this. How about the window glass? Yeah, because what the window that I'm using, I think is already energy saving glass. So no, it doesn't really contribute much if I change to other materials. So I just maintain as it is. So right now the only option that I can change to the design is probably manipulating my the window to wall ratio and my western wall. Let's look at the window shades on the north. Ah, it seems that if this is the current in the model. So let's say if I change the sunshade to 2 out of 10, the window height. So I will be able to reduce around 2 kilowatts per hour. So I think that can be one option. How about another wall? Not much difference, so I might just ignore this. Let's look at the southern. Yeah, not much difference also. Same goes to the window shades as well as the window glass. There's not much difference. So I just the only thing that might need to change is the window shades on the north, as well as the window to wall ratio on the western wall. Let's look at the eastern side. If I change it to 0%, uh, I'll be able to reduce by 2 kilowatt per hour. So but I still want to have opening. So this is where you need you need to decide if the changes is not that significant. This is where you need to decide whether it is worth it to not having an opening at the eastern side. You need to also consider on the view factor as well and so on. So if the reduction is not that significant, so you might can just ignore it, or perhaps you can propose a better materials perhaps for your building by using triple OE glass or whatsoever. So by having window shades, I will able by 2 to 3 I can reduce by 187. It's quite huge. So it's quite okay if you put it on the yeah. Right. So perhaps another important energy saving opportunity is by manipulating the operating schedule. So if you notice in the bay model, it is set as default. So let's say if I change the operating schedule for the building to only 12 hours, 5 days per week, I will be able to do significant amount to my design, which is 156, which is quite a lot actually. Yeah. So in total, yeah, I will able to reduce 1 to 136 by manipulating the window shades on the north, the window to wall ratio on the western wall, the window shades on the east, as well as as well as to reduce the operating schedule for the building. So in this case, it is quite relevant because office usually operates from Monday until Friday, so you don't need to have 24/7 operating schedule. So by reducing the scheduling, the operation schedule will significantly affect the energy reduction, as well as perhaps if you want to use PV panels. So let's say if you want to manipulate 90% of the surface of the roof surface, you'll be able to reduce. You'll be also able to reduce a lot of energy. Okay, so yeah, this here can also be another option uh, in order to reduce the energy consumption for the building. So in a nutshell, this widget is basically reporting the baseline energy and consumption of your building. So you can basically inspect all of these widgets and somehow strategize as well as to decide which option might be suitable in order to to reduce the energy consumption of my building. So it will be a great decision making tool for the architects, before they want to uh, revise their design and so on. And it will somehow benefit the architect in terms of having an energy efficient design. So once you are happy with this, you can just go back to inside. Okay, you can just click back and maybe go to your Revit model and revise all the changes, and maybe you can resend the energy model back to inside to compare between the baseline as well as the optimized scheme. So yeah, perhaps we will. All right, guys. So right now, I have made some amendments to my design. So if you can see that I have, put in some sun shadings to the north, east, as well as the south facade, as well as I have deleted the window in the west facade. So hopefully by doing these two design changes, I will be able to optimize the energy usage of my building even more. So before you want to create a new energy model on this, I would advise you to save this project as a new project. So the previous model is basically the baseline model. So for this revised model, you might want to save it as a perhaps a revision one. Okay, so make sure that you save this model as another file. You rename it to revision one or revision two, and then simply create that energy model. So in this case, I have already created the energy model. Okay, so this is the energy model that I have created. So notice that there's some small changes, particularly on the sun shading, as well as there's no window in the energy model. And yeah, and then it's also the same. If you want to send it to inside, you need to click generate and update a new energy analytical model. Don't use the existing one, or else it's going to override the previous analysis. So you want to create a new analysis, so you just click this. So I have already sent the model to inside. Okay, so this is the model that I have sent. So if you notice that I managed to reduce just some fraction amount of amount of kilowatt hours as to compare with my baseline model. Okay, so yeah, at least there's some reduction on it. So So previously it was 198. So by doing these two changes, I managed to reduce by 7 kilowatt hours. So it's quite a significant reduction in terms of energy usage. And perhaps to further optimize the design, maybe I would need to play around with the operating schedule, which I didn't change in the model yet, right? Yeah, as well as perhaps by playing with the preview panel as well. So yeah, I hope that this exercise will help you guys to actually assess the energy usage of your design, and hopefully it will guide you in proposing alternative design strategies or any green design strategies to be applied to your building. So all right, guys. So this will be the end of the demonstration. But before that, I have something to share. Hold on. Right. So if you're still unsure about how to do analysis, energy analysis, and so on, there are some video references that you can refer to. So have a look at all of these link. Okay. I will share the slides later on in times. So this is just to strengthen up your understanding on how to use Autodesk Revit as well as Insight for energy analysis. And you are also required to answer this tutorial attendance exercise. Okay, so it's quite a simple exercise. So using your project one model, so you need to use your project one model, run a baseline energy analysis. So when we talk about baseline, it's basically the basic uh, energy analysis of your project one. And after you have run the analysis, please explain in your own words the action as well as strategies that you will undertake in order to further optimize the energy consumption of your building. Okay, so yeah, I will provide a Google form so you can answer in the Google form. So I will share the uh, Google form or questions in times. So you might. So please go to week 10 tab and try and find this link, tutorial attendance questions, and answer the question as well as to submit the screenshot of the analysis. So yeah, when you talk about the screenshot, is basically the inside page. Okay, so try and screenshot it and submit it together with your write up. Okay, so if there's any questions, you can always contact us via WhatsApp. As well as we will also run a Revit clinic throughout the whole week. So if you have any uncertainty or anything to discuss with regard to the software, you can contact us during your assigned tutorial sessions. All right, so thank you very much for listening. Have fun in doing your exercise. So thank you very much.